Welcome to our discussion of valid arguments and fallacies. Our only objective for this video is to identify some common fallacies in arguments. Okay, so an argument consists of a series of logical statements, and we just try to determine if they're true or false. Now, in those statements, we have a premise and a conclusion. The premise is the part at the beginning of an argument that is used to support the conclusion, and then, of course, the conclusion is the ending statement of your argument. Now, premise and conclusion are relative terms. They really refer to the position in the argument. So it's not like something is always a premise and something is always a conclusion as far as the statements are concerned. It's more about where they land in the statement. There are certain words that help us figure out which part of the statement is the premise and the conclusion. Just think of these are all kind of if-thens. And anything that's the if part or the given part is the premise, and then the then part is the conclusion, right? If this happens, then this. So if then, given this, therefore that, or given this, thus that. So you can see the groups of words, these are all kind of if words, and these are all kind of then words. So try this one. Go ahead and pause the video and see if you can figure them out. Were you able to identify the premise as the technology will deliver a better product? Thus, right? So it's kind of like if our technology will deliver, then you will have fewer complaints. If you build a communal break time to the workday, then your employees will feel better and be more productive. You see how you can kind of throw if-thens in front of them? So inductive reasoning is a line of argument that takes specific examples and uses those as a premise and then draws some sort of general conclusion from those examples. Deductive reasoning, however, uses statements that are already kind of commonly accepted as facts and then makes a case for a certain conclusion. A valid argument is just a deductive argument where the conclusion is guaranteed from the premises. So all we're doing is trying to identify valid arguments and then fallacies. So here are some examples of valid arguments. All men are mortal, right? See, that's given. That's common kind of yes, we know that to be true. Socrates is a man, well, really was a man because he's dead. And so those two things we know to be true, and then therefore we can conclude that Socrates is mortal. Green Day makes great music. Their new album was just released. Therefore, it must be great. So it's kind of like we assume Green Day makes new music, or sorry, makes great music to be fact. And then their new album was just released. We assume that that's fact. And really the key there is that it's their new album. And because it's their new album and they make great music, therefore it must be great. It's kind of the, an if-then kind of thing. And then cutting out sweets from your diet makes you lose weight. If we accept that to be true, that's kind of like an if-then statement. And then we say he hasn't eaten sweets in months, so therefore he must be losing weight. Those are all valid arguments. And we can work through them pretty quickly and pretty easily. All men are mortal, right? Socrates is a man. Basically, therefore Socrates is immortal is basically saying if one is a man, then he is mortal. P implies Q. And if we assume P to Q is true, then we assume, then we look at the Socrates case and we consider the truth table and we can see that we are assuming both P and Q, we are assuming both P and P implies Q are true. So we only look at those rows where both P and Q is true. So this row, and that's it, right? Because this one is true, but this one is false. Down here we have these are true, but these are false. So this is the only row where both P and P implies Q are true. Therefore, Q must be true. So just to review on this, right? The first part of our argument is really considered to be a conditional. All men are mortal basically says if you're a man, then you're immortal, right? If you're a man, then you're mortal. Where being a man, right, is P, and then being mortal is Q. Then we look at the second statement, of Socrates being a man, and then the last one is, well, then therefore he must be mortal. So P implies Q, we assume is true. Then Socrates is a man, right? That's P, because being a man is the statement. So this person is a man. So that's a P. So if we're given that this is true, and we're given that the second statement also must be true, then we're basically asking, well, then is Q true, right? And this is kind of how they do them with symbols a lot. Is they'll put the symbols and they'll put a little line down here, and then they'll put these three little dots, which means a therefore. And you're basically asking yourself, is it true that if all the stuff above the line is true, then can we make that conclusion below the line? And we just saw that we could. How about this one? Show that arguments 2 and 3 are valid by using the same method given in example 1. All right, were you able to come up with this? The first line expressed as, again, a conditional. And if we take that to be true, and P implies Q ensures that when P is true, Q is true, consequently we can conclude that Q is true because we're given that information, right? So if you go back to it, Green Day makes great music, their new album was just released, therefore it must be great. All right, what about the third one? Again, we have a conditional. If you cut out sweets, then you will lose weight. Since we know that he's not eaten any sweets, that is, he's cut out sweets, P is satisfied, right? Because the P statement is if you cut out sweets, and then they say he's cut out sweets. So they're basically saying P implies Q is true and P is true, and if we take those two things to be true, then Q is true given that P is true, right? P implies Q is true, so we're living only on these three rows, but then they tell us P is true, right? So out of these 3 rows, this is the only one where P is true, so we're now left with this row, which means Q has to be true, and that's why we can conclude that he's losing weight. Okay? All right, an invalid argument is an argument where the conclusion isn't guaranteed. It's basically, if we go back and do this technique again, we're not left with a case where Q could only be one letter. It doesn't necessarily have to be that we only have one row that works. It's just that in those rows, whatever we're looking at has to always have the same letter, right? They have to be all T's or all F's type of thing. So if we rearrange argument 3 and reword it to something that sounds kind of the same, right? Cutting out sweets makes you lose weight. He hasn't eaten sweets in months, so he must be losing weight. Well, it's actually quite different. We still have our first statement of cutting out sweets makes you lose weight, which is really the same thing as saying, so cutting out sweets, that's going to be P, and then losing weight, that's going to be Q. And that initial statement, can you all see, is P implies Q, right? If you cut out sweets, then you will lose weight. Now, he hasn't eaten any sweets. So this statement here, I'll put it in green, he hasn't eaten sweets in months. Well, not eating sweets is the same thing as cutting out sweets. So that's P. And if we also assume that is true, we're now going to ask ourselves, so, right, can we say, therefore, he must be losing weight? And remember, must be losing weight, that's just Q. So we have, if P implies Q is true, and P is true, does that imply Q must be true? Now, what we have here is the original argument. If we apply it to the new argument, we'll see how it changes things. We still have this same first thing, right? Which means everything is still the same here. We still have cutting out sweets as P. We still have losing weight as Q. And we still have P implies Q. But now the second statement says he's losing weight, so he must be cutting out sweets. So this is the premise, this is the conclusion, right? The so is the therefore, that's the conclusion. So instead of our original structure of this, we now have P implies Q, and then he's losing weight is Q, and then we're asking for P, right? Quite different. We're saying this is true, does that force P to be true? Well, if we look at the table, we're now saying this is true and this is true, which happens here and here. But in that case, A is true, but A is also false. And because it can be one or the other, it's no longer a valid argument. And that's basically what I'm explaining here. Okay, how about trying this one? Pause it, give it a try. Here's your solution. Now, did you come up with a false statement because of the real world, right? If we present the organism has wings as P and the organism can fly as Q, then the first statement basically becomes P implies Q. If something has, or if an organism has wings, then it can fly. So P implies Q. We already know that's a false statement because we know there's a bunch of things with wings that can't fly, penguins being one of them. Now, since we know penguins have wings, P is true of penguins. So we now have, remember, when we're doing these arguments, all the stuff above the line we assume to be true. So we assume P implies Q is true, even though in the real world it is not, right? So we assume that if you have wings, you can fly is a true statement. And then penguins have wings, so we assume that to be a true statement. So if those two things are true, if we take P implies Q to be true and P to be true, then it forces Q to be true, and we can conclude that Q is true of penguins and that they can fly. But of course, we know that's wrong in the real world. So the argument is in fact logically valid, even though it's false. But why is it false? It's false because we had a bad assumption, right? We assumed P implies Q was true, which we know to be false in the real world. So that's where these things can get tricky. Because if they gave this to you on a test and said, is it a valid argument? The answer would be yes, it's a valid argument. It's not a true argument, it's a valid argument. Two completely different things. Okay, a sound argument is just a valid argument using true premises. So here's an example. Use the truth table to show that the following is a sound argument. If the President of the United States is unable to carry out his or her constitutional role, then the Vice President becomes the President of the United States. In November 1963, President John F. Kennedy was fatally shot. Therefore, without an election, Lyndon Johnson became President of the United States. Obviously, you have to know that Lyndon Johnson was the Vice President at that time. Otherwise, this wouldn't make sense, but there you go. So, P is the statement that the President of the United States is unable to carry out his or her constitutional role, and Q is the statement that the Vice President becomes the President of the United States. Based on that, we know that first statement is an if-then, so it's a P implies Q. So we're only going to consider the first two rows of the table. Why are we doing that? Well, you can see that the implication is true on the first, third, and fourth lines, i.e., this statement is true here, here, and here. So we must start with a true statement. So that means row 2 just kind of like doesn't exist in our world. Okay. Now, in order for a statement to be sound, we have to start with a true statement, kind of a true premise. And so because of that, we can only use the first two rows because those are the only ones where P is true. So, in other words, statement P must be true. And we are told that statement Q is true in this argument because the Vice President became President. And from the truth table, we know that when statements P and Q are both true, the implication P implies Q is also true. So this is a valid argument, but because we started with a true statement of P, it's also a sound argument, right? So the only difference between a sound argument and a valid argument is a sound argument is a valid argument that uses true premises. So it's kind of like it's valid, but it also works in the real world, so to speak. Here's another example. We'll go skiing this weekend if it snows at least 2 inches, and if we go skiing, I'll get some new boots. It snowed 3 inches, so I must have new boots. So let's start by identifying each of the little statements and then write everything out in symbols. So P is going to be it snows at least 2 inches, Q is going to be we go skiing, R is going to be I get new boots. So bring the original statement back in and we can verify what's going on here. We go skiing this weekend if it snows at least 2 inches. Well, we go skiing if it snows at least 2 inches. So isn't that if P, then we go skiing, Q. And then we go, and if we go skiing, so if we go skiing, that's Q. So if Q, then I will get new boots. Those are our first two premises, our first two pieces of the argument. Then the last piece says, okay, we're also told it snowed 3 inches, which means P happened. All of this stuff is above the line, and we're asking if all that stuff happens, then can we say, therefore, that's my so, right? Therefore, I must have new boots. Therefore, R. So if this is true, and this is true, and this is true, does that make R true? All right, here's our big truth table. We got 3 letters, so we've got 8 rows. Plug everything in, do all of our conditionals, and then what the heck does this mean? Well, we begin with the premise that it snowed 3 inches, which ensures the truth of P. So if we go back to our truth table, we basically can ignore all of the things that don't have P being true. We're assured that P is true. So these rows are all out. Okay? Now we know from the truth table for implications that if we have a true P and a true P implies Q, we can conclude Q. Because whenever P implies Q is true and we have a true P, that only happens when we also have a true Q. Okay? That's what that statement's saying. That's something we've already seen. So we can conclude that we do indeed go skiing. Then going one more step, it also allows us to combine this new conclusion Q with Q implies R to conclude R and ensure that I get new boots. All right, what does all of this junk mean? Well, remember this. We're given that these things are all true. So let me write this on the other slide so we can have it all in one place. We're told that everything I circle in green is true. This has to be true, this has to be true, and this has to be true. Well, we eliminated everything where P is not true, so we can now eliminate these because that's where this one wasn't true. Then we can eliminate this one because that's where that one's false. And we can see that the top row is the only place where those 3 statements are all in fact true, which leaves us with only one option for P implies R, which is true, which means R has to be true, right? Because if P implies R is true and P is given to be true, then we know R is true. But really, we also just get that from the table. This is the only row left, and in that row, R is true. So this is really the technique that I teach students that's the easiest when you're trying to determine valid arguments, is draw out your truth table, and then based on what you are given as true things, just start scratching off all the rows where that thing is false. So if you're given that P has to be true, you can scratch off the bottom 4 rows. And then if you're given P implies Q has to be true, then you can scratch off these 2 rows because that's where it's false. And you just keep doing that until you've done that for all the premises. And then whatever's left, you basically look at what your conclusion is. And if your conclusion piece is true, then the argument is valid. If your conclusion piece is not true, then it's not valid. So you can try it on this one. And here's the solution. More explanation of the solution. Okay, fallacy, the last thing we really want to talk about, is just when you have an error in reasoning. Now, there are many different types of fallacies. There are a lot of words for them. It's a lot of vocabulary if you want to try and remember them. I wouldn't recommend it, but here they are, some common fallacies that come up a lot. Here's an example of identifying a fallacy. And then false dilemma was the first one, post hoc, ergo propter hoc, and so on and so forth. You can try this one. And the last thing I'm going to do is just going to show you kind of some descriptions if you want to screen capture these. But I try not to concern myself with learning all these names. It's just a lot of stuff. Hopefully you're not taking a class where they want you to identify what kind of fallacy it is. It's really just nice if you can just identify a valid argument or not using the technique we talked about with scratching off rows of your tables.